viewers. Welcome to Simplified Maths class. Our topic is Matrices, part 2. In the last part of Matrices, we were able to handle the introductory aspect of matrices. We were able to solve problems that involved order of matrices, and then we handled addition and subtraction of matrices. This time in Matrices part 2, we'll be going into the multiplication of matrices. And in the multiplication, we have first the scalar multiplication and then the vector multiplication. Multiplication of matrices. Of course, we are still in matrix. That's matrix part 2. All right. Now, the first one is the scalar multiplication. In the scalar multiplication, we are supposed to multiply a given matrix by a single element known as a scalar. Now, you'll be given a matrix and you'll be given a scalar. All you need to do is to multiply the matrix by the scalar. The scalar is a positive or negative whole number or fraction. That's what the scalar is. Now, watch this. Now, this is a matrix A. And the matrix is given as now you'll be asked to multiply. Assuming we are asked to find minus 2a. We are asked to find minus 2a. It means all we need to do is to multiply the matrix A by the scalar minus 2. Now, our minus 2a will be equals to minus 2 into the matrix 4. So to find minus 2a means we should use the scalar minus 2 and multiply by the matrix A. That gives what we call scalar multiplication. So we are going to have minus 2a to be equals to minus 2 times 4, that's minus 8. Minus 2 times minus 3, that's a positive 6. Minus 2 times 7, that's a negative 14. Minus 2 times minus 2, that's a positive 4. Minus 2 times 8, that's a negative 16. And minus 2 times 3, that's a negative 6. So what we've just done is to find minus 2a. That's the scalar multiplication. You can also be asked to find, let's say, half a. This time around, they say we should find half a. The scalar now is half and the matrix is a. So our half a will be to take half and multiply by the matrix 4 minus 3, 7. 8 and 3. So we have to multiply matrix A by the scalar, which is half. The scalar can be a negative, a positive number or fraction. Now let's multiply. So we're going to have half of 4 will give us half of 3 negative, that will be negative 3 over 2. That's minus 3 times 1 is minus 3 over 2. That's what you have. Half times 7 over 2 will give us half times 7 will give us 7 over 2. That's 7 times 7 over 2. Half times negative 2, that will give us a negative 1. That's 2 times 2. 2 times 1 here will be 2 over 2, which is 1. Then the negative sign. And then half of 8 is 4. And then half of 3, of course, is 3 over 2. So what we've just done is also scalar multiplication, because we are multiplying the matrix by the scalar half. Now, but the most important aspect of it is when we are asked to find the vector multiplication. So let's go into the vector multiplication. Vector multiplication. So in the vector multiplication, we are supposed to multiply a given matrix by another matrix. Now, but you have to understand that in vector multiplication, the only condition for you to multiply a matrix, say A, by another matrix, say B, the only condition is the two matrices must be conformal. Must be conformal. By conformality, we mean that the number of columns in matrix A must equal the number of rows in matrix B. Watch this out. Assuming you're given two matrices A and B to multiply, watch this. A and B. Now these are two matrices. If you look at them, you see that they are not of the same order. Addition and subtraction is what you consider the dealing matrices. But when we are talking about multiplication, vector multiplication, what you consider is their conformality. Are the two matrices conformal? How do we know that? Now this makes rows and columns. How many rows do we have? 1, 2, 3. We have 3 rows. How many columns do we have? 1, 2, 3. So we have in matrix B. How many rows do we have? 3 rows. And then how many columns do we have? Columns. So for you to multiply the given matrix, you must consider this. You must consider this. The number of columns in matrix A must equal the number of rows in matrix B. And of course, you can see that the number of columns in matrix A equals the number of rows in matrix B. 3, 3. So it means that the two matrices are conformal. You can go ahead to multiply. How to multiply? The rule is there is an arrow here pointing this way, and then there is an arrow this way pointing this way. So that's how multiplication is done, following these arrows. How do we do that? It therefore means that A times B, which is the vector multiplication of A and B. Watch. Now, when we take these elements, we'll multiply by this, by this. When we take these elements, we'll multiply by this, by this. When we take these elements, we'll multiply by this, by this. It means as we take a step to the right in matrix A, we are rather taking a step downwards in matrix B. That's how the multiplication is done. So watch me. So I'll take 2, multiply by 2. I take 1, multiply by 3. Then I take 3, multiply by 1. So as I take a step to the right, I'm taking a step backwards. I'm done with this multiplying by this. So I'm going to this multiply by this other one. So 2 times 1. I take a step, 1 times 2. And then I take a step, 3 times 4. So I'm done with this first row. I'm taking the second row. So I take a step down. 3 times 2. 2 times 3. 1 times 1. I take it backward. 3 times this other one. 2 times 2. And then 1 times 4. So I'm done with this row. I take the last row. 1. 1 times 2. 0 times 3. 2 times 1. I go back again. 1 times 1. 0 times 2. 2 times 4. So I am done with the multiplication. Now I need to find the result. So we are going to have 2 times 2 here is 4, plus 1 times 3 is 3, plus 3 times 1 is 3. The other side, 2 times 1 is 2, plus 1 times 2 is 2, plus 3 times 4 is 12. I move to the next line. 3 times 2 is 6 plus 2 times 3 is 6 plus 1 times 1 is 1. 3 times 1 is 3 plus 2 times 2 is 4 plus 1 times 4 is 4. Then we take the last one. 1 times 2 is 2 plus 0 times 3 is 0 plus 2 times 1 is 2. And then the last one. 1 times 1 is 1 plus 0 times 2, 0 plus 2 times 4, 8. Now we are going to have this. So 4 plus 3, that's 7, plus 3, 10. 2 plus 2, 4, plus 12, 16. 6 plus 6, 12. 6 plus 6, 12 plus 1, that gives us 13. 6, 6, 1. 3 plus 4, 7. 7 plus 4, 11. And finally 2 plus 0, 2 plus 2, 4. And then 1 plus 0, 1 plus 8, 9. So A times B, which is the vector multiplication of the two matrices, gives you this. And please take note, since we had used this to this for conformality, notice that if I cross this and this, that gave us the conformality. What I will have is a 3 by 2 matrix will be the result. And that's what we have here, a 3 by 2 matrix. 3 rows and 2 columns. Why? Because conformality has been crossed out. The result will be a 3 by 2 matrix. And what we have here is a 3 by 2 matrix. So please take note, the only way you can multiply matrices is when they are of conformality, when they agree with the conformality rule, meaning that the number of columns in matrix A, the given matrix, the first given matrix, must be equal to the number of rows in the second given matrix. So by that it means they are conformal. Take note of that. In our next slide, I want us to be looking at the determinants of matrices. But when we are dealing with determinants, we are talking about square matrices. And in the determinants of matrices, square matrices, we'll be dealing with how to find the determinants of a 2 by 2 matrix, a 3 by 3 matrix, and a 4 by 4 matrix as it will be. So we can now introduce Cramer's rule in solving simultaneous equations that has to do with 2 unknown, 2 variables, and simultaneous equations that has to do with 3 variables, 3 unknown. This is what we call Cramer's rule. Please, I want you to like my video, subscribe to the video, so that when the next slide that has to do with matrix 3 has this important concept of determinants and Cramer's rule, you won't miss out. Thank you very much and God bless you. Cheers.